Good morning, students. Our next concept is types of matrices. In this one, first one is square matrix. Okay, a matrix, any matrix is said to be a square matrix if m is equal to n. Here m is equal to n. Here m and n are nothing. But if you generally any matrix is the order of any matrix is denoted by m by n. Okay, m by n. In this one, m is number of rows, n is number of columns. So a matrix is said to be square matrix means if m is equal to n, that means it is in the form of sum n by n. That means number of rows is equal to number of columns. So let us, that means number of rows is equal to number of columns, then that is a square matrix. Let us take one example. So here 1, 2, 3, 4. Okay, it is a matrix. See here number of rows 2, number of columns 2. So it is a square matrix. So don't say always a square matrix in the form of 2 by 2 order. Okay, it is either 1 by 1, 2 by 2, 3 by 3, 4 by 4, 5 by 5, 6 by 6. Anyone you can write. Okay. Next one is rectangular matrix. Rectangular matrix means, so you understand very clearly, if m is not equal to n. Okay, if number of rows is not equal to number of columns, then that matrix is called rectangular matrix. So example you take 1, 2, 3, 4, 5, 6. Okay, this is a matrix with order here. Number of rows is equal to 2. First always you should write rows only. Okay, number of columns 3. So here rows is not equal to columns. So it is a rectangular matrix. Okay, next one is horizontal matrix. Horizontal matrix means very clearly it may be a rectangular matrix also. Okay, that means when you observe the matrix, it seems so it will be horizontally, that means length will be more, width will be less. So when it is possible, when number of rows is less than number of columns, then you can say in that shape. Okay, see here, that means when you observe, that means horizontal means length will be more. So when it is possible, so number of rows is equal to, example if you take, number of rows is equal to 2, number of columns is equal to 3. So then you get that shape. So here m is less than n. So first one, number of rows is when less than number of columns, then that matrix is called horizontal matrix. Next one is vertical matrix. So you can understand, if width is more, length is less, then that shape says vertical matrix. Okay, when it is possible, so number of rows is more than number of columns. Okay, here it is the order 3 by 2. So number of rows is equal to 3, number of columns is equal to 2. Okay, so when it is possible, so here number of rows is more than number of columns. So m is greater than n. Whatever maybe you take matrix, if m is greater than n, that is a rectangular matrix also called vertical matrix. Whenever horizontal matrix m is less than n, also called rectangular matrix also, no problem. In particularly, you can say if m is less than n, horizontal matrix, if m is greater than n, vertical matrix. These two matrices are nothing but rectangular matrices also. Okay. Next one is row matrix. Row matrix means in that one, in that matrix, if only one row and columns may be more. More means more than one. One or more than one, no problem. Okay, but rows will be only one. Columns will be one or more than one, no problem. Then that matrix is called row matrix. That means row matrix means m is equal to 1 and n, here n is nothing but number of columns. Columns may be any integer, no problem. Any integer you can take. So let us take the example. It is one by one. So here column and rows are same. So this matrix is called row matrix. Okay. So because of number of rows is equal to 1. So 1 2. So only one row, two columns, 1 by 2. So number of rows is equal to 1. 1 2 3 up to n entries if you write in horizontally. So here number of rows is 1 only, but number of columns is n columns are there. So it is also a row matrix. Next, column matrix. Call in the same reverse of row matrix. In the column matrix, number of columns is equal to 1 and number of rows will be any integer. That means number of rows will be 1 or more than 1, no problem. That should be belongs to integer only, natural numbers. Okay. Integer means here natural numbers, positive integers. Okay, here example you take, here 1, this is 1 by 1, here only one entry. In this one I gave only one entry. If one entry means that order is 1 by 1 only. If you observe row or column, that is 1 only. So 1 by 1. So whenever you take like this matrix, what would you say? So is it row matrix or column matrix? We can call any one, no problem. Both are same here. So here number of rows 1, number of columns 1. So this type of matrices we can call as either row matrix or column matrix, no problem. But here if you go for 1 2, number of rows is equal to 2, number of column is 1 only. So 2 by 1, this is exactly called column matrix. 1 2 3 up to n. If you write vertically up to m. Okay, so number of rows is equal to m and number of column is 1 only. So it is also m by 1. So it is also called column matrix. Okay, so row matrix, column matrix. So these definitions are very important, because of in questions they may ask like that only with its name, column matrix or row matrix, horizontal matrix. They may ask in that word by using those words also. So you should remember the types of matrices. Next one is upper triangular matrix. A square matrix is said to be upper triangular matrix if all the elements below the diagonal is 0. Okay. See here there is a new word, diagonal. So we didn't discuss till now. So before completing this upper triangular matrix, first we have to discuss about diagonal of a matrix. Okay, that one you call as principal diagonal also. Okay, see here in general matrix, if you go for general matrix of m by n. Okay, so generally you understand principal diagonal comes in square matrix only. So let us consider it is n by n. It is also n. That means it is a square matrix. Okay. So here understand here a11, a12, a13 and so on a1n, a21, a22, a23 and so on a2n, a31, a32, a33 and so on a3n. Here you understand an1, an2, an3, ann whenever it is a square matrix. Okay. So from top left to right bottom. Okay, top left to right bottom means this is. Okay, so here a11, a22, a33, all I is equal to j. Okay, in this general form I is equal to j means a11, a22, a33 and so on ann. You understand it, if it is a square matrix, m is equal to n, it is then ann. So the diagonal consists of a11, a22, a33 and so on ann is called principal diagonal of a matrix or diagonal of a matrix. Actually we may get one more diagonal like this in this one also. You don't use these elements consists of diagonal. Okay, we are not calling as diagonal. Okay, so this one only the diagonal, a11, a22, a33 and so on ann. See, understand, after that this diagonal upper elements, diagonal upper elements if you observe a12, a13, a1n, a23 and so on a2n. A3. Here, if you A33 means after that A34, A35, A36 up to A3n. Like that you understand. So here A12, A13 and so on A1n means here I is less than j, because I is small number. Here also I is small number, j is big number. I is small number, j is big number. If from A23, A24, A3, sorry, A23, A24, A25 and so on A2n, here also I is less than j. If you go for A34, A3, after A33 what you get? A34, A35, A36 and so on. So here also I is less than j. That means principal diagonal elements, upper elements of principal diagonal or diagonal of a matrix, square matrix, are in the form of I is less than j. If you observe the lower elements, A21, A31, A32, AM1, AM2 and so on. Here 2 is more than 1. Here 3 is more than 1, 3 is more than 2. M is more than 1. That means here AN1, last number, A up to ANN, AN by N you are taking. So understand here N1, N2, N3 if it is N by N matrix. So N1 means N is the big number, 1 is the small number. N is the big number, 2 is the small number. N is the big number, 3 is the small number. Up to before ANN, you get I is greater than J. That means principal diagonal elements are diagonal elements of a matrix. Upper elements are in the form of Aij, for which I is less than J. Lower elements are in the form of Aij, where for which I is greater than J. Lower elements, I is greater than J. Upper elements, I is less than J. Remember. Okay. So based on this one. So first I am going to give the definition of diagonal of a matrix. If A is equal to Aij is a square matrix of order n. Here if they didn't mention n by n, if they given only order n means here n by n. If they given order 2 means 2 by 2, order 3 means 3 by 3. That means it is a square matrix, you understand. So both the columns and rows will be same. Then elements or entries A11, A22, A33 and so on ANN are said to be constitute the diagonal of the matrix A. A11, A22, A33 and so on ANN are said to be constitute the diagonal of the matrix A. For example, if you take, I am giving simplest 3 by 3 matrix, 1 minus 3, 1, 2, 4 minus 1, 3, 5, 6. Here it is the A11 element, A12, A13, A21, A22, A23, A31, A32, A33. Here these elements constitute the diagonal. That means A11, it is A22, it is A33. Okay. Then the elements of the diagonal of A are nothing but 1, 4, 6. Okay. So now come to the point here. A square matrix is said to be upper triangular matrix if all the elements below the diagonal is 0. If all the elements below the diagonal is 0. That is Aij is equal to, below the diagonal how it will be? Aij such that I is greater than J. Already I explained here. Below the diagonal elements, I explained below the diagonal elements means all these are. Okay. Here all are nothing but I is greater than J. Okay. So such elements all are zeros. Such elements all are zeros. So these three elements are zeros. Okay. For suppose if it go for one example, 3 by 3, 1, 2, 3, 0, 4, 3, 0, 0, 6. Okay. Here observe here. This is the diagonal elements. Below elements all are zeros. Okay. You may have one more example. 103, 003, 006. Observe here. These are the principal diagonal element. So in this principal diagonals, in the diagonal, some of the elements may be 0, no problem. Upper elements also may be 0. But if you want to say this is upper triangular matrix, all the elements below the diagonal will be 0. That is the important. Remaining may be 0 or may not be 0. We don't bother about them. Okay. So remaining elements don't see. If you want to say that is upper triangular matrix, below the diagonal, all elements are zeros or not. That is the important. Okay. Next one. Based on this one, if you go for one example, the minimum number of zeros in the upper triangular matrix of order n by n is n into n minus 1 by 2.